Hello, everyone. Welcome to this session on Introduction to Machine Learning. The topic for today's discussion is going to be K-means clustering. It is the unsupervised clustering technique, and we have covered previously KNN, which is K nearest neighbors, which is also a clustering technique. So it is a bit different from KNN. In KNN, K stands for the number of neighbors that we are going to look at while clustering. Here, in K means clustering, K stands for the number of clusters that I want to divide my data into. Okay, so we will try to keep this in mind, and let's start with K means clustering. So K-means clustering is an unsupervised learning algorithm that will attempt to group similar clusters together in your data. Okay. So in many of the real life data science applications, we have data in which we want to cluster the data into different groups. For example, the data can be about customers, right? So I want to club different kind of customers together with respect to their spending capacity. Okay, so some customers are highly valued customers who spend a lot on the particular e-commerce website or in a mall or in any shopping complex. Some customers are like the middle range spenders, and some customers are like belong to the class which spend a very low amount, right? So there can be like low, medium, high classes in which I want to club my customers into, so that I can pitch them different offers based on their spending capacities or based on their previous spending levels, right? Some other examples can be clustering similar documents together, right? So clustering is a technique. So everyday life we want to club similar, so I want to club similar movies together. Okay, so action movies, like genres we have in on Netflix, Amazon Prime, we have genres. So action movies all clustered into one particular tab. All the dramatic and horror movies are clubbed into one separate tab. All the comedy movies are clubbed together. So clustering is a form of grouping things together based on some kind of a similarity, right? So we can cluster similar documents together. We can cluster customers based on some features. We can do market segmentation. We can identify similar physical groups. Okay, we all of us have seen people in schools and colleges. They roam in clusters, right? So cluster of friends, so maybe they belong to the same class, maybe they belong to the same lobby in the hostel rooms, maybe they belong to, so maybe they are just friends, they are a part of a football team, they are a part of cricket team, maybe they belong to the dramatics club. So they all the people in general form clusters based on their some kind of similarity. Okay, so the overall goal is to divide data into distinct groups such that the observation within each group are similar. Okay, so the ultimate aim of clustering is to divide data into some groups where the data points or the members of a particular group are similar to each other than the other group, right? So here you can see, like on the left hand side, this is a particular data distributed, right? This black color shows like currently no clusters have been formed, but we can see that there are some clusters, right? If you go deep, right? So there are some small clusters where like these groups, these data points are closer to this particular data, and this one is different, right? So I can divide this into these five clusters. Okay, or if you want to not do in five, then I can clearly see like there is one big cluster over here and there is a big cluster over here. If I want to divide it into two groups. Okay, so this is what the ultimate goal of clustering is. So I have my data like this, I want to get an output like this where I know what all data points belong to which cluster, right? So this picture explains the complete process or the complete essence of k-means. So on the left hand side, I have my normal data which is distributed in two dimensions. Currently, for visualization purposes, we are using two dimensions so that we can picturize what my data looks like. It can be applied to multiple dimensions, 3, 4, 5, or even 10 dimensions. Okay, so my data is currently like this. Suppose these are the customers and I want to get three groups. Okay, so these are like middle value, high valued, and the average value customers, right? Like this, I want to get groups or clusters after applying k-means. Okay, now let's try to break down the complete procedure of k-means algorithm. Okay, in k-means, the k stands for number of groups I want, and means is the method that I'm applying to group them together. So means, like I will be taking the average of the whole group. Okay, in order to classify the every data point to each and every cluster, right? So let's look at the procedure, right? So choose a number of clusters case. So I have to choose in how many clusters I want to group my data into. Okay, this may come from previous experience, maybe from some domain knowledge, or maybe after studying the problem, right? So for example, we took the example of customers. So three looks nice because I want to club them in on the basis of their spending capacity, like low, medium, high. Okay, so I want to put all the customers of Flipkart or Amazon into these three categories, right? I can club them into maybe 5 or 10 categories also. So like very low, very mediumly low, or like there can be three levels in low, three levels in high, and three levels in medium. Okay, depending on some range, but it is meaningful to put them into three groups as of now. Also, like in any other case, where like suppose I'm doing cluster analysis of of patients of a particular disease, right? So I can club them into like two groups. So it is serious or non-serious, right? Like we saw in the previous example where the tumor is malignant or benign. So here the number of clusters can be two. Or if we're talking about any serious disease which comes in multiple stages, so I can it is meaningful to divide the group into those many clusters, like level 1, level 2, level 3, level 4, right? Or level 5, how many levels are known. It will be good if to go through the domain knowledge or refer to the documentation for deciding how many clusters I want. Next step is randomly assign each point to a cluster. So we'll start with assuming all the points belong to any one of the clusters randomly, right? And next, these are the two most important steps. So until clusters stop changing, repeat the following. For each cluster, compute the cluster centroid by taking the mean vector of points in the cluster. Okay, so once all the data points have been assigned to any random one of the random clusters, then I will again find out the centroid of each cluster. Right, centroid of each cluster is like the mean of the data for our application. We can take the mean because this algorithm is k means. So I will take the mean of each cluster, then that particular mean becomes the new centroid of my data of my cluster. Then I again all the points reassign all the points to the new cluster centers based on their distance from distance of all the data points from the cluster centers, right? Assign each data point to the cluster from which the centroid is the closest. So here the centroid like is centroid means the mean, or in case of our in a 2D graph or in a 2D visualization, it is the central point of any shape that we draw, right? So if this is my shape, then the centroid is somewhere like this. If suppose this is my shape, right, the centroid is going to be like somewhere here, like the central point. Okay, so let's look at like graphically all the steps, right? So this was initially my data, all points are black. I'm randomly assigning all the points into three clusters because I have chosen the k value to be 3. The value of k here is I'm taking 3. I want to divide this data into three different clusters. So I have assigned randomly all the points to three groups, right? These three color shows three clusters. Or I can just randomly assign three cluster points. I can take 3 points randomly, 3 points to be the cluster centers, right? So based on this particular distribution, I found out the cluster means. So this is what I found. These are the cluster means, like one cluster, second cluster, and third cluster mean. It is a centroid of the clusters. Now based on this particular centroid, I reassign all the points, right? So all the points which are closer to this particular centroid belongs to this orange group. All the data points which are closer to this particular green centroid belong to the green group, green cluster. All the data points which are closer to the pink centroid are belonging to the will fall into the pink centroid or the pink cluster. Now, once I have divided all the points into the new clusters, then I will again find the central mean, centroid of the cluster. So like this is my one cluster, its centroid will be somewhere here. Like this, we saw the yellow centroid is shifted from this position. The centroid shifted to the center of the clusters formed. Right. Similarly, the green group is here. The green cluster is here. Now I again found the centroid of this particular cluster. So the clusters moved toward the center. Here came the green cluster center, and here comes the pink cluster center. Now since I have redistributed the centroids, again I will assign all the points to this new cluster, right? Because after this redistribution, I will check all the points one by one, and I will assign all the data points to the nearest cluster, right? So some of these points who previously belonged to the yellow class, now they became a part of the pink class, some of them became the part of the green class, right? And again I found the cluster center. So I will keep doing this, like I will keep assigning all the points to the closest cluster centroid, and keep finding the centroid of the cluster once all the points have been assigned. So after some point, after some iterations, the data points will stop changing, right? So even after making the new cluster points, the data point redistribution will not will not change, right? So the all the data points belonging to this group will remain here same only, and the data points belonging to this cluster will remain the same only, they will not change, right? So we should stop at that particular position, so we can get arrive at a final clustering result. Okay, this is the cluster. We started from a cluster like this, where the centers were here. After iterating, we got three clusters: yellow, red, and or green, and with these cluster centers. This is the whole k means clustering algorithm, right? Now let's look at some of the steps again, right? So choose the number of clusters. First step. Second, select at random k points, the centroids, which need not necessarily be from your data set. So I can clearly choose any randomly three or any number, any k points to be the cluster centers. Then assign each data point to the closest centroid, right? So I will assign all the data points to the closest centroid. Suppose in our example we took three clusters, then we assigned three data points, three cluster centers. In our case, it was the center at this center, right? I can assign it anywhere. Assign each data point to the closest centroid. So we assigned all the data points to the closest centroid in this particular step. Next, compute and place the new centroid of each cluster. Now we computed the new centroid and placed here. This is the new centroid, new centroid, and new centroid, right? The third step is reassign each data point to the new closest centroid. Okay, now after calculating the new centroid, I will reassign all the data points to the new closest centroid. If any reassignment took place, go to step 4. If like there are some reassignments, again you go to step 4. Again you compute the cluster center. Again you assign all the data points to the new cluster centers. Otherwise, if no points change, then our model is ready. We can just stop the algorithm, right? So let's one more time, let's look at all the steps. So this is my first step: choose the number of clusters. Suppose we choose 2 in this particular data distribution. I want to divide this data into 2 clusters. Next step is select at random k point. Suppose this point is one cluster center, this point is another cluster center. This is I randomly chose, and they are not belonging to my data points. So I chose a point here and I chose a point here. They need not to be a part of my data distribution. Okay, now third point is assign each point to the closest centroid. So I need to assign all the points to the closest centroid, right? So like I will find the distance of this point from this point, and I will assign this to this group. This point is closer to blue one, it belongs to the blue cluster. This point is closer to the blue point, it belongs to the blue cluster. All these points belong to the red cluster. So I will find a distance. What kind of distance? Currently we are using the Euclidean distance, like a 2 point distance in like we learned in geometry. There are other measures of difference or other measures of distance which we can use. So we can choose any kind of distance that we want. So currently we are taking into account the Euclidean distance, the distance between 2 points, right? So all the closest I can assign all the points to the nearest centroid. Okay, so one cool trick is to draw this perpendicular bisector line. So all the points are lying in this region are closer to the red point, because this is a perpendicular bisector. All the points on this line are equidistant from red and blue centroids. All the points which lie on this side are closer to the red point. All the points which lie on this side are closer to the blue centroid. So that's why we assigned all the points to blue and red group, right? Now since all my points have been assigned to a particular cluster, now I will again find the cluster centroids. So this is the new cluster centroid, this is a new cluster centroid, right? Now I moved the cluster centroid to this points. Now I will again, because these are the new cluster center, I will reassign all the points to the nearest cluster center. So I again draw this perpendicular bisector line, and I will again see this point was previously red, it will now belong to blue, and these 2 points are previously blue will now belong to the red cluster. So after these changes, I will again find the new cluster centers. I will move the centroids to the new cluster center positions. Then I will again draw a line, right? So I will, like, this is blue and this is blue. I think nothing will change from now. So after this reassignment, I will again find the cluster centers, and after finding the cluster centers, I shifted all my centroids to the new cluster center position. Right now, after once I have shifted this, see, this point was previously a part of the red one, it became a part of the blue cluster now. Right now, I will again move the centroid, find the new centroid, and I will do reassignment after drawing this perpendicular bisector line. But now see, there are no changes to be made. So this was the previous case. This was the case here also. Now no more changes are to be made. So I have finally found our model is ready. We have found our two clusters. Okay, this is our two clusters that we found out from our k-means algorithm. Now a question arises: how to choose a value for k? Like how many clusters or how many clusters I should draw, right? So obviously it depends on the domain knowledge. It comes as a part of the problem, or from experience you can tell, or there is a mathematical way of doing this, right? So for the same data, I can do two clusters, right? Red and blue. I can do three clusters also: green, red, and blue. I can do four clusters: green, red, yellow, and blue. Okay, there is no red. I can do five clusters. I can do six clusters. I can do seven clusters. I can do 10 clusters. So which value to choose? So there is a method. There is no easy answer for choosing the best value of k. There is one elbow method, right? So because any number of clusters that we choose, we always have some sum of squared errors, right? So the best way to do is that you keep clusters from 2, 3, 4, 5, 6, 7, 8, 9 up to certain limit. For all these number of clusters, you find out the total sum of squared errors. Okay, and this error, as the number of clusters increase, the error is going to decrease, right? So but at after a certain number of clusters, the decrease in the sum of squared error is abrupt, and you can actually see it in form of a elbow in the graph, right? So we will plot a graph of sum of squared errors with the number of clusters, right? So we will try out the k-means algorithm on multiple of using multiple cluster centers or multiple values of k, and we will choose that particular value of k where the decrease in uh, uh, sum of squared errors is abrupt, okay, or sudden. Where we see a sudden decrease in sum of squared errors, we'll choose that particular value. So SSE is defined as the sum of square distances between each member of the cluster and its centroid. Okay, so SSE is the sum of squared error. So what is the distance of each cluster member to its centroid, right? So if you plot k against the SSE, you will see that the error decreases as k gets larger. Because when the number of cluster increases, they should be smaller. So distortion is smaller, right? This is because as we increase the number of clusters, so suppose for a particular data point, so there are like, if I'm taking this one big cluster, so there will be a larger error, right? But for the same data point, if I'm taking multiple like these three clusters, then my error within these each cluster is smaller as compared to the one big cluster. So as the number of clusters increase, they become smaller in size, so error also increase, distortion also is smaller. The idea of elbow method is to choose the value of k at which the SSE decreases abruptly. This produces an elbow effect. Elbow effect means it looks like an elbow, like a proper curve is there, sharp curve is there in the graph, as you can see in the following picture, right? Like this. So on the y, I have within group sum of square, or within cluster sum of squares, and here I have number of clusters. So this thing becomes in like an elbow, right? So this particular point, so like this, it is decreasing, and at this particular point it becomes kind of a constant, right? So it is very advisable to choose like this value or this value of or sum of squared of clusters, right? This value of k, maybe 7 or 8. 7 we can take, or like that. Okay, so this is how we select the value of k, and this is what I have to discuss in respect to k-means clustering. Thank you for your time. I'll see you in the next lecture, which will be the Python implementation of k-means clustering.